Oh, I'm looking at the game's top score. I want the player's top score. Excuse me. Another drink of coffee.
Thank you to Roxy and MDI Group for providing the food. Roxy, do you want to come say hi?
Yeah. All right. Hi. What?
Nothing.
I'm Roxy. I bring food every other month, and I like to hang out with you guys. So yeah, I'm with MDI Group. We're actually a motion recruitment company because we just got merged. But yeah, we do recruiting and staffing and all the things that we can for our consultants. And yeah, and then on a couple times a month, I get to bring food and hang out with you guys and learn some stuff. So that's why I'm here. So I'll be sitting over there eating food with you.
Thank you for sponsoring, Roxy.
Yeah, my pleasure.
I get to ask the question that you can't. Who's looking for a job? There you go. Who has jobs that they'd like to pitch?
So I just started working for Deloitte last month. I'm a developer, not a recruiter, but surprisingly, a lot of people have never heard of Deloitte. I don't know how that's possible, but in case you're one of them who doesn't know anything about Deloitte, they're the biggest consulting company in the world, close to 300,000 employees throughout the world. But we have a new campus right down the road at Pecos and Gilbert Road. It's going to be about 3,000 people in a few years. It's about 300 right now. Pretty much all developers and people along those lines, DBAs, all sorts of different technical disciplines. We're looking for C#, well, .NET developers right now. Like I said, I'm a developer, so I just started, so I could answer some questions if you guys have questions later on, but I'll stick around after everything is over and you know, if anybody's looking for that, I'll talk.
Awesome. Deloitte sounds really cool.
Yeah, I like it so far. I love it. I mean, I just started there, but I love it so far.
Yeah. Way out in the Southeast Valley.
Yeah, from here it's not far, but for people
Yeah.
who live more towards the central district.
Right.
So.
People commuting up from Tucson is easy, right?
Yeah, it actually probably would be faster from there than if you lived in central Phoenix.
Yeah,
Yeah,
exactly.
or the west side. I know people, I've worked with people in the past that lived on the west side. Yeah, I live, you know, for people who live here, it's a nice commute. But yeah, if you're
Yeah.
coming from Tempe, I actually used to live in Tempe and made the commute this way to another company in that area. And the commute isn't so bad coming that way.
Because you're going the other way.
Right, exactly. It's horrible. I've made the commute in the other direction. It's horrible. But even if you live in the Phoenix, Tempe area, it's really not that bad.
That's cool. Anyone else have gigs they want to pitch? Awesome. Upcoming events. The Visual Studio 2019 launch event is April 2nd. That will be online, which is really elegant. April 16th, we're going to do a live Visual Studio 2019 launch party at Gangplank, and that'll be all day. Do we have a Galvanize? Thank you. Do we have a Meetup page?
It's under the Northwest Valley.net user group.
Awesome. So you'll find it under the Southeast Valley.net user group, a page that'll redirect you off to the Northwest Valley.net user group, where you can sign up to that event. And so we'll be at Galvanize, which is right downtown. What other events are coming up soon?
I'm sorry, I was talking. Can you repeat what that was?
The Visual Studio launch party
Oh,
will be April 16th at Galvanize. It's all day. And Visual Studio 2019 is awesome.
I don't know if I'd like calling it a launch party. It's a launch event.
A launch event, not a launch party.
More of a one-day conference kind of thing, right?
Ooh, yeah, one-day conference. I hear the speakers are going to be pretty good.
They're some awesome.
Yeah.
Well, at least one of them. I don't know about the two of you. I'll be great.
Yeah. What other events are coming up? Tax Day's awesome.
My birthday, April 3rd.
There you go. April 1st, April Fool's Day for all the things except for Microsoft employees. Apparently April Fool's Day has been canceled at Microsoft.
Is there a punchline?
Nope.
Okay.
Microsoft just sent out a memo that said no April Fool's Day pranks.
That's the prank.
Maybe. Awesome. So we're excited to have Steve. Steve came out to visit us from Seattle, And Steve's going to talk to us about all things AWS.
Well, all things .NET
All things .NET.
on AWS.
Yeah. Thanks, Steve.
All right, thank you. All right, so as Rob said, I'm Steve Roberts. I'm Senior Technical Evangelist at AWS now. Can you mic me? You can mic me if you want, or I can shout. Well, our voice is hoarse after last night. Do you want a mic? Are we good?
Only for recording.
All right.
I don't think we have it overhead anyway.
All right, I'll try and shout. So anyway, I'm going to speak about .NET Core and PowerShell dev on AWS. And usually when we go out to talk to these communities people, we get a, wait, AWS does .NET, right? It's kind of this hidden secret, but we have an awesome set of tools for working with .NET Core and PowerShell on AWS. And that's what I want to show off tonight. There are not too many slides. I'm going to start with the who am I, because why not? Been at AWS now for 8 years, and for 7 3/4 of those years, thereabouts, I was a senior dev working on the .NET tools. So I worked on all 3 versions of our SDK, C# SDK, the toolkit for Visual Studio, the dev lead for the tools for PowerShell, and the tools for Visual Studio Team Services, which is now Azure DevOps. I will toggle between DevOps and VSTS all night. I still have not got the naming in my head right. And last year I helped get the toolkit for Visual Studio Code off the floor, which is great because we released that in preview to the marketplace today. It doesn't yet support .NET, that's coming with the GA release, but you can get started with serverless workflows in VS Code with the new toolkit. And we also announced today the toolkit for Visual Studio now supports VS 2019. So that's what we're going to be using tonight. But last November I switched over to being a technical evangelist with a specialism for .NET and PowerShell. So having worked on all these really cool tools, I now get to go and visit communities, conferences, etc., and talk about them, which is even better. And I still get to contribute back to them on the odd occasion. So tonight, as I mentioned, I'm going to give an overview and the occasional dive into working with .NET Core and PowerShell on AWS, trying to get everybody on the sort of level set on what we have available. But what do I mean with working with? Right, so what I'm going to be doing is showing 2 things. I'm going to start with writing code, or I've actually pre-written the code, of how you access AWS services from your applications. So AWS has over 165 different services. We have SDKs that support all those services in different languages: C#, Ruby, Java, JavaScript, C++, Go. I'm bound to have missed a few. We'll be using C#, obviously. But then once you've put access to an AWS service or services inside your application, then how do you get your code running on AWS? What are the different ways you can get that .NET code or .NET Core code or even PowerShell actually working on AWS? So we're going to go into that. What we're going to use, the SDK for .NET. Then I'm going to show you the toolkit for Visual Studio. We're going to start off by deploying web applications to Elastic Beanstalk. So have any of you used AWS yet? Just one? Okay, of course this is new to everybody. So Elastic Beanstalk is our sort of platform as a service, right? It takes care of spinning up the resources to host your application. You have some control over the compute horsepower that you want that application to be hosted on, but in general it abstracts away the resource infrastructure. You just take care of your code and say, hey, host this for me, right? Then we're going to take a look at PowerShell, and we're going to show you how you can build a complete VPC or virtual private cloud network infrastructure from script. So these are not just commands that you can execute at the command line just to query things. You can actually do real work, infrastructure as code management from these tools. So rather than going to the console, the AWS console, and click around and build a VPC, we can do it from script. And then we can reuse that. Right? And then inside that VPC, we're going to have some EC2 compute instances, or our VMs launched, and we're going to deploy some code to it using AWS Code Deploy service. So this takes your application bundle and a set of script files that control how it gets laid down on that compute instance and do the deployment that way. Contrast that to the Elastic Beanstalk approach. Then we'll take a look at deploying from Azure DevOps, and then I'm going to finish up with an application or a couple of applications. One, deploying serverless to Elastic Container Service. So again, the idea here is that you worry about your code, you hand it off to someone and say, hey, just host this for me, right? You build the Docker containers, clusters, etc. I don't want to be concerned with any of that. I just want to worry about my code. And then a set of landing step functions that I've been working on recently, I say recently, began last week, for illustrating how to use step functions in C#. All right? Sound good? Enough slides. That's it. I'm done. I don't do slide talks. So I'm going to sit down and put my big boy glasses on. which I can't see any of you, but I can see my keyboard just fine. And let's get started with looking at using a service from an application. And this is not your typical application, it's just a console, .NET Core app. But the idea is that I want to write an application that uses Amazon S3. So that's our distributed object storage service, right? Built with, I think, 11 nines of durability and resilience. The way S3 works is you have something called a bucket, right? And you can create more than one bucket, but you have a bucket, and inside the bucket are the objects that you want to store. And those objects are identified by a key, right? Now, S3 is not a file store, it's an object store, right? As far as S3 is concerned, these are just blobs of data. The keys look like paths, but they're not really. So what this program is going to do, I want two things. I want to list the buckets I have available in my account, right? Just echo them to the console, just to show how this works. And then we're going to get, for a given bucket, list me the objects in that bucket, all right? Just to show you how you start work with S3. So the first thing you would do, if you were using our SDK for .NET, which is distributed on NuGet, you're going to get the NuGet packages. Now, I said that Amazon has over 165 services currently. Each service is its own NuGet package for this SDK. Right? So here I've got the S3 package, SDK.S3, and if you scroll down on the right-hand side, you'll see all the platforms it supports. So .NET 3.5, .NET 4.5, PCL, Net Standard, all supported. And it's the same set of APIs across all those platforms. The difference is if you're using .NET 3.5, if you're still using .NET 3.5, then it uses the begin-end async pattern. If you're using 4.5 or .NET Core, it uses the new task-based. Right? So there are some slight differences in the methods you have available to you. In fact, if you're using Net 3.5 and Net 4.5, then you also have access to synchronous APIs. So you'll see there's like, for 4.5, there's a list buckets and a list buckets async methods. Right? If you're using Net Core, you only have async. Sometimes that trips people up, they go looking for the synchronous version.
Is this code available for us online, Ryan?
Yes, the SDK is fully open sourced. In
I meant
fact,
your demo code.
I can make it available. It doesn't do very much, but I can certainly make it available, yeah. Before we get started, I want to point out this page. This is the .NET homepage on AWS. So aws.amazon.com/net will take you here. So from here, you can get all of the tools, documentation, etc., on everything I'm going to show tonight. And if you go to GitHub, github.com/aws/.net, this is the central homepage for all of the .NET open source tooling on GitHub. So you can get access to the SDK itself, which is all open sourced, the extension libraries, because we don't just have NuGet packages for the actual services themselves. We have some higher level NuGet packages to do authentication and other bits and pieces. These are all here. You can get to .NET development tools where those are open source, etc. So 2 URLs to remember tonight. I'll summarize them in a slide at the end. So back in my code, having added the dependency on the S3 NuGet package, what does my code look like? So here's my program, and what I've done is I've added a couple of namespaces. So the way that we surface services in the SDK is consistent across all the packages. Every service has a top-level namespace, in this case Amazon.S3, right? Inside there, you'll find the client class that represents, that you're going to instantiate to call S3, or whatever service it is you want to call. Inside the model namespace, that's where you'll find all the request and response classes that you're going to use to program against the service, plus any other shapes or C# classes that are going to be used. Now what the SDK does for you, it abstracts away the actual wire mechanism calling the service. Right? If you look at the docs for S3, for example, you'll see that they're written in a style of a REST API. They have like put, get operations. The SDK exposes things like get object, list buckets, etc. The logical operations. In turn, different services have different body content on the wire. Some use XML, some use JSON. Right? The SDK abstracts all that away. All you do is you fill out a request class that says these are my input parameters of the operation. You call the operation and it gives you back a response, a typed class with the results. Right? So very simple, consistent pattern. And you'll find that pattern across all of the SDKs, no matter what the language is, because they all generate from the same service models. So in my code here, what I'm going to do is I'm going to instantiate the new S3 client object, right? If I go and take a look at that client, time, this is the S3 client. You can see it implements an interface called iAmazon S3. If you take a look at that, these are all of the APIs available for S3, right? Exposed as just normal C# methods. Right? You'll see here that I'm instantiating the client and I'm giving it a specific region that I want it to use. So AWS is a regionalized cloud, right? The resources in one cloud, the resources in one region cannot be seen in another region, right? With slight exceptions. There are some services that we consider global, like identity and access management. But in general, services like S3, EC2, the compute instance, etc., they are all regionalized. So you need to construct a client for the right region that you're going to be calling against. So in this code, I ended up so that if I don't pass in any arguments, I just want it to list my buckets, right? And I'm going to give it the S3 client I want to use. So here's list buckets to show you how you use this. You'll see that I just form up. In this case, I'm calling the list buckets async method because this is .NET Core. And you'll notice I'm not actually giving it a request object. Right? I could have just put in there a new list buckets request. The thing is, list buckets request has no parameters in it. Right? So the SDK has an overload that just makes this convenient. It doesn't always consistently do this, but for S3 it did. Get rid of that. Okay. So let's just run this code and just see what happens. Buckets. Okay. Nothing too spectacular UI-wise. Not really focused on that, but those are all the listed buckets in my account. You can see they all have names. They're all globally unique names. That's one thing you need to remember with S3. When you create a bucket, it is URL addressable. And it has to have a globally unique name, all lowercase. It doesn't mean it's public by any means, but it is globally addressable. Now, how did I get that list? You can see here that the object that came back from the call, list buckets async, is a list buckets response, which is in that model namespace. You can see it contains a list of S3 bucket objects, right, and an owner. The SDK has deserialized all that data that came back on the wire into C# classes for you to use, so it makes it really easy. Let's do something a little bit more interesting now. Let's actually go and take a look at the objects I have inside that bucket. So if I'm going to give it a bucket name, change the debug properties for this to pass in a bucket name that I have. Debug, just call it Steve at AWS. Oops, Steve at AWS. Okay. So back in the code, to list my objects in a bucket, I'm going to give it the bucket name. You know, I remember saying that objects are identified by a key. It's kind of a key path. It has slashes in it, right? So you can filter down through specific key paths by giving it the prefix, what we call a prefix. I'm calling it a key path here. But here's an example. You can see me newing up a request object for the particular operation I'm going to call. In this case, a list objects request class, and I need to give it the bucket name. I can pass through that key prefix to the prefix member if I gave it one. And then I'm going to do what looks like a fairly funky looking loop. You'll see that next marker thing, right? By default, when you call list objects against an S3 bucket, it returns up to 1,000 elements in the bucket, 1,000 keys. Right? Therefore, if you have more than 1,000, you need to paginate, and that's a common pattern across a lot of the AWS APIs. Right? We don't know how much data is going to be in there. S3 has trillions of objects inside it. You may not have trillions in your account, but you may certainly have more than a few thousand. So it will give you the first 1,000, and it will give you back a marker value that you then call on pass on the next call. Say, give me the next 1,000. You don't have to get 1,000. You can get 10 at a time if you want. That's up to you, right? But you go through this pagination loop. And that's what we're doing here. So set next marker to null to start with. We pass that into the request class, and then we just call the method. Get me the first 1,000 objects in this bucket. For each object that comes back, and you'll see it's a typed object, that object has a list of S3 objects that the SDK is deserialized for you. It has the name of the bucket, the key, when it was last modified, the owner, etc. All we're going to do is just write out the key. and then keep a count of how many you got, and then if the next marker has a value in it, go back around the loop. All right? Really easy. So this will spin through several thousand objects that I have sitting in that bucket in pages of 1,000. So 5,067 objects in that bucket. Everybody doing so far? It's a fairly simple coding pattern, right? Yeah?
Is it actually pulling back the data too, or
No,
just the marker?
just the keys. That's just pulling back the keys. If you want to actually get the object content, then it's a separate API call. I'm not going to run that, but I will show you how to do it. I have some code here to do uploads. So how do you upload an object to an S3 storage bucket? Which is something you might do in an app, right? You write an app that's taking data from somewhere, you just want to store it in S3 because some other process is going to process that later on. We're going to see that at the end. S3 has a number of APIs for uploading objects. The first one, the simplest one, is called put object, or put in S3 terms. And this is suitable for, I say, small content, less than 5 meg. Right? It's a single call, single HTTP call. Oh, by the way, all the endpoints to AWS are HTTPS by default. You can't get past that. So when I say HTTP call, I mean HTTP over HTTPS. Right? It's a single call, and all you do is you, again, using your client, you instantiate a put object request, the bucket I want to put it in, the key path, or sorry, the file path here to the file on the local disk. You can use a stream if you want, and then the key that you want to get is stored under, right, which can have slashes in it. Single call to upload, fairly simple. What if it's more than 5 meg? Right? That can obviously time out if your connection's flaky. So S3 has a set of multi-part upload APIs, we call multi-part uploads. And what you do in this process is you basically, you tell S3 you're about to upload an object of certain size, right? You then divide that object into logical 5 megabyte chunks or larger. 5 meg is the minimum size for each part. And then you upload each part in a loop. And you can do that async if you want. At the end of that process, you call S3 and say, I'm done, complete multi-part upload. S3 will then assemble that object in store in the right order, and you're done. It's a fairly simple process, to be honest. I didn't bother coding it up here because there's actually a better way of doing it from an API, from an application perspective. And that's using something called the transfer utility. This is one of those higher level APIs that we have in the SDK. Java has a similar, I think they call it transfer manager, not transfer utility, but pretty simple. What you do is you instantiate a transfer utility instance, which is in the amazon.s3.transfer namespace, giving it the S3 client you want to use. And then you just call upload async. And you give it a transfer utility upload request. Looks very similar to put object, right? Under the covers, what the SDK will do is it will take a look at that file or the stream. The stream has to be, you better query the size of the stream. But it will then take a look at the object and say if it's more than 5 meg or less than 5 meg, I will just use a single put object call on your behalf. If it's more than 5 meg, it'll break it down into chunks and do a multi-part upload. So you don't need to care, right? You just call transfer utility upload. The other nice thing it has that I produce is you can do a multi-part upload, a transfer of an entire folder hierarchy to S3 with a single call. And these have event progress delegates on them, so you can listen to the events, etc. I'll do one with PowerShell later on, you'll see it. Come back with progress updates. So is everybody with me so far on how you code against AWS services in your application, right? We have this client object that implements an interface that is the service API, right? And then in the model namespace, we have classes, requests. They're all operation name request, operation name response, typed classes with all the additional C# classes available for subsidiary data like S3 object, S3 bucket. All the services look the same. So once you start programming with one, it's a familiar pattern to program with all the others. Later on in the step functions one, I'm going to make use of multiple services in that pattern. Okay, so let's say that we've written our application. It's a web application, right? .NET, for sake of argument, and I want to get that hosted on AWS. Right? What's the simplest way to do it? Well, we use Elastic Beanstalk. And to do it, we can use the AWS Toolkit for Visual Studio. So you'll see on the left-hand side here, I have this AWS Explorer window. This is what you get when you install the toolkit. So if you go to Extensions, Manage Extensions, this is VS 2019, and you search online for AWS, you'll see this entry here, which we just released today for 2019. Once you download and install that, it'll actually, the first time you run it, if you don't have any AWS credentials locally, I'm going to go into credentials in a second, it'll pop up a nice window in here that'll let you import credentials from AWS, right? I obviously have credentials set up, so it's not going to prompt me. But under the View menu, you have this AWS Explorer entry. That will give you this window here. And the idea behind this window is it's surfacing a bunch of services that are useful from a development perspective, a day-to-day development, trying to get your feet wet with AWS or just managing some simple resources inside your IDE. So I don't have to go away to the AWS console to work with like EC2 or S3 or DynamoDB, etc. I can do it directly from inside my IDE. The way I get started with this is I need to give it credentials. So AWS credentials are a form of an access key and a secret key, right? And you can paste them in here, or you can import from a CSV file. How do I get these? Well, I would go to, if I was a developer, I would go to the management console, log in, and then under services, I would search for identity and access management. And under users, I would do add user. So here I've got a bunch that I use. Is the one I'm using currently. Go to security credentials and then generate access keys. Right? When you generate the access key, it'll give you the access key ID and it'll give you the secret access key. You only get that access key, secret access key once. Right, so make a note of it or download the CSV file and then import it into Visual Studio. Now, in that code that I was running earlier, one window, this here, when I instantiated the S3 client at the beginning, I only specified a region, right? Normally you would actually specify the actual access key and secret key that you need to run. And there's a couple of ways you can do this. You can actually put the access key and secret key into your code. Sure, it'll work. It's a really, really bad idea because you're going to check that into GitHub at some point and then guess what's going to happen, right? So keep them out of your code. What you do is you store them in something called a credential profile. And back in Visual Studio, let me just jump back to this one here. These are credential profiles. Credential profiles have a logical name, and we can reference that inside our code. So in that bucket code that I just showed you at the top, here's an example of the code. If you wanted to use a specific credential profile in your code, right? Safe to put this on GitHub. No one else, that doesn't tell you anything about the profile that I have. The actual values aren't there. The values are stored in a couple of places. So if we go to, if you're on Windows, then there is a toolkit store file, and I'm mentioning this for a specific reason. It's going to become apparent. And it is toolkit. You see this file here, registered accounts? This is where the credential profiles that you create inside Visual Studio or PowerShell if you're on Windows by default live. So take a look at it. You can see that each profile has a name, right? Here's the display name. You can see the access key and secret key, except they're encrypted, right? They're encrypted for this account, or my account, that I'm logged into on Windows, on this machine. This file cannot be used anywhere else, by anyone else, right? We call this the secure store credential, okay? I mention it because we get a bunch of people ask, or they try to put this file onto an EC2 compute instance and then run their application. Right? That won't work, right? Because it can't decrypt it. It's a different account. Right? There is a plain text version of the credentials file. That one lives in a .aws folder here called credentials, but it is plain text. I'm not going to open it because we're being recorded, and it's my keys. That's what we call the CLI credential file, or the shared credential file. The toolkit and the SDK, in fact all the .NET tools, can read both credential files, and it fuses them together into one logical set of credential profiles. So inside my code for that bucket lister, where I did not specify credentials, what's happening? Right? I also didn't give it a profile name. The SDK, if you don't give it a profile name, or give it a profile name that doesn't exist on the local system, will look to see, is there a profile called default? If there is, it'll use that, right? Automatically. If you're running code on an EC2 compute instance, or Elastic Container Service instance, then your application code can get credentials automatically from the environment when you start it with a role, and I'll show a role later on. Right? So you don't need to put credentials in your code. Don't do it. Right? It's a really bad idea. You don't even need to put them in like an app settings file or a web config file. Just leave them out. Right? I'm set up so that the credential profile I'm using, Steve Dev in this particular case, is also copied into my profile called default. And that's why that code for the bucket lister worked. He just found that profile automatically and just worked. Right? That's the way I tend to work these days, for local development anyway. Makes things a lot easier. Anyway, back to this particular application. So what this is going to do, and don't laugh at my UI skills, but basically this is going to take that code that we saw earlier for listing buckets and just present it on an ASP.NET page. Nothing more special than that. So what I've done is I've gone into the references here, added a NuGet package for S3. I've also added X-ray so I can trace what's going on the API calls to S3 from inside my application. So let's get this deployed onto AWS. So if we're using Elastic Beanstalk, you'll see it's actually visible inside the Edit Explorer. And that's because we have a nice wizard inside the toolkit that will help you deploy and get started. When you deploy to Beanstalk, you have something called, this expands, an application. This is the top level resource in Beanstalk. You get multiple applications. Right? Inside an application is something called an environment. This expands. Oh, open. Open for me. Right, here's the application. The environment is what is the environment is the actual resources running in the cloud. Right? That's the compute instances and any other resources that you deployed. To get started deploying, you just simply right-click on your project, publish to AWS Elastic Beanstalk. Starts this wizard. You can create a new app environment. In fact, let's just do that. Let's call it Simple Net Application 2. And then I'm going to give my environment a name, and then the toolkit will suggest a URL for the endpoint for the application, and I can check, is that available? It is, good. To use that, hit next. Now remember I said that Beanstalk is abstracting away the resource, the infrastructure that it's running on, but this is where you get to control the size of that. So Beanstalk uses something called solution stacks. Here it says container type, but basically there are a bunch of solution stacks that define the resources that will be launched, the EC2 compute instance that we launched, the image ID, etc. Is instance type, so the toolkit will always default to the latest available one automatically. The instance type is the size of the VM, the size of the EC2 compute instance that we're going to launch. Right? And there are a whole bunch of these inside the toolkit. Let's just go with a M1X large, why not? A key pair is a PEM file, SSH PEM file, that allows you to remote into EC2 instances without needing to use password. So passwords are generated dynamically when the compute instance launches. If the toolkit has the key pair details loaded locally, I'll show you in a second, we can remote into that instance without needing to give it a password. It will decrypt on the fly for us, which is really useful. I can deploy into a virtual private cloud if I have one set up from inside the wizard, or in this case I'm going to use a single instance, just one EC2 compute instance. If I'm using relational database service and you've got SQL Server in there, I can actually, this will actually light up and list all my relational database service databases. And then what the wizard can do is actually wire up my Beanstalk application in the cloud so it can talk to the database. Because by default it can't. Right? AWS has a very fine-grained permissions model, and by default it won't let you do anything. Okay, next. I'm going to come to these in a second, but basically what this is saying is when my application is deployed onto Beanstalk, I'm going to have it running under the concept of a role. That role is scoping what my application can do, right? So we saw in that code it's going to list buckets. Therefore, it needs to access S3, and it needs to get S3's list buckets API. You with me? That's what that role's controlling. I can choose any role that I have. In this case, I have one already for Elastic Beanstalk. I'm going to show you what it looks like. In fact, let's go and take a look at it now while we're here. So again, back in the Identity Access Management console, under roles, here's my Elastic Beanstalk EC2 role that I set up. And you'll see if I show this. These are the policies that allow what my application can do when it's deployed in the cloud. All right? Because it has X-ray, which is the tracing service turned on, I need access to X-ray. But here's S3 read-only. If I expand this, see there's a policy summary. Give me in JSON format. Here we go. And you can see this is saying allow access to S3 to the get and the list APIs on any resource, i.e. on any bucket. Okay? I can lock this down to a specific bucket. I can lock it down to a specific object or a key path for a set of objects. Right? Very, very fine-grained permissions. This also allows the code, which is going to be running on an EC2 compute instance, that's what Beanstalk's going to spin up, to assume a role, to assume this role and get credentials automatically. So I don't need to deploy credentials with my app. Those credentials are temporary. They will recycle every, I think it's 60 minutes or something, right? So there's no need for me to deploy credentials or set any credentials up on this instance. I just set up a role, give it a trust relationship, and attach the policies that I want for my application to use when it's running. Let's carry on with the wizard. We'll set those two. Right, I get some options of do I want to ship the debug or release build, etc. What do I want the application path to be on the iOS web server? Turn on some tracing, enhance health, environment variables, etc. The toolkit will auto-populate a version label based on the current time in milliseconds, or ticks I think it is. But you're free to put any value in here, V1, V2, V3, whatever you want to use. An application contains those versions over time, so you could roll back to a particular version if you want and just redeploy it. And it goes wrong. And click next, and then deploy. So what the toolkit does for you at this point is it's going to build a web deploy package. It's going to execute MS build with a package target on your application to create a zip file, web deploy zip file. It's going to upload it to S3, and then it's going to set up the Elastic Beanstalk infrastructure for a new application and a new environment. Right? And then it'll trace send back the events that it starts to launch, so the environment created is up and running. This will just spin back a few events over time, which is not that interesting to look at. So let's go and take a look at one I deployed earlier on. Animation comes up. Come on, wake up. Oh, you can see this created the first resource, the security group. The security group controls the access from the internet to that instance. In this case, it's opened up port 80, right? Otherwise, you're not going to be able to talk to the web server. Open. So this is one that I launched earlier this morning. You can see over time I've been doing multiple deployments to this thing. As it deploys out, or I do an update, I get a new event. In fact, let's just do a redeploy. So if I was going to redeploy this, so here's my applications down here that I've got launched and my environments. So the one I want is this one. Next, let's just assume I've made a change. Finish, deploy. Builds the web deploy archive, sends it to S3, and tells Beanstalk, hey, go deploy these new bits on the instance, or the set of instances if you create more than one. Right? Really, really simple, really, really fast deployment. If you're getting your feet wet on AWS, you just want to get a web application hosted, this is probably the fastest way to do it, right? From within your IDE. Just work it that way. So you'll see this will now come back and say, hey, I'm updating. Cool. We'll let this finish. See what the other application's up to. I'm waiting for EC2 instances to launch under the cover. And that. See how we do. Refresh faster. Have you ever noticed in live demos things update slower? It's just weird, right? How does it know? There we go. So the application updates. So deploying the new. So the web deploy package has now been downloaded to the EC2 instances that are running this application or hosting this application, and now it's actually just unpacking the web deploy archive onto the instances. While we're doing this, let's just show you. So over time, I mentioned that applications hold multiple versions. So here's all the versions that I have available for that application in that particular environment, right? So if something went wrong, I could just select a version here and publish that particular one and roll back. And you can do this through API control as well. You don't need to do it through the toolkit or PowerShell. So app version updates completed. Should transition back to ready to go. A few more seconds.
I build my project inside C, users, username, documents, Visual Studio 2015, projects,
Yep.
some company. And so I build that web deploy package, and it also duplicates that path.
Yeah.
I've done deployments to Elastic Beanstalk, where it then unzips that thing, which duplicates the path and blows up 260
Yep.
characters. Is there a solution to that other
There
than
is.
move my repository on my local machine?
That was the solution up until recently. I discovered that Microsoft has a registry switch that turns off the 260 character limit. I can't remember for the life of me what the switch is now, but that's what I use.
Some of the time, there are Microsoft applications that say, yeah, so what?
Yeah.
Nuget being one of them.
Yeah. Yeah, it is a pain. I did go through a process where I would move my entire app up higher and build into there until I found that switch. So far, it hasn't failed for me, but yeah, that can be a problem. Certainly with web deploy. Oh, environment is healthy. Okay. So up here you see the URL to the application. Let's just click that. Now, as I said, don't laugh at my UI skills, right? But this is just an ASP.NET sample, and you can see here the list of buckets that we showed earlier on in the console, right? So my app successfully called S3. How do I know? Well, apart from seeing that, remember I turned on the X-ray support? That's another one of our services. So I can actually go and take a look at what happened when I made that call. So let's take this back to the last 15 minutes. It's computing a map. Inside my code, while that computes the map, let me show you what I did. So inside my my code here, I added support for the X-ray NuGet packages for the SDK, and then I registered an application, and then in my controller, and there's different places you can do this, but in my controller, I turned on X-ray for all services. That now integrates with the SDK client classes to instrument them when they're actually running in the host environment. Right? Alternatively, I could have just registered for just Amazon S3 here. Right? The upside of doing this is that I can then trace the performance through the cloud. So here's my request coming in that I just hit when I went to that home page. You can see I called S3. Take a look at the trace that went on here. I'm no expert at digging into these traces, but you can see that various bits of time, 14.2 minutes, that one's quite old. To 531 milliseconds, 1.4 minutes ago. Let's see what happened. So here was the application call come in, and there was the call to list buckets. And if I'm calling multiple services, they would all get listed out here, if that's the way it's registered, right? I'd encourage you to dig into this. It's actually quite interesting what you can get, especially if you're using lambdas and serverless functions, where you're not controlling the hardware or the infrastructure. Sometimes it can be a bit of a mystery what's going on. So let's say ASP.NET. What about ASP.NET Core? Right? Everyone agree that's kind of a relatively simple way of getting started, right? Just run that wizard, and you can go through that loop, redeploy, redeploy, redeploy. It's really quick. ASP.NET Core, you do the same thing. So inside the toolkit, once again, we have publish to Beanstalk. The difference is that this will detect that we're running .NET Core, and we'll do a .NET Publish instead of a web deploy archive. All that's abstracted away from you. It still does the .NET Publish, it gets the zip file, sends S3, tells Beanstalk, go do. Right? So I won't redeploy this one to save some time, but here's my application. And again, you can see that it comes up. Right, I've been busy playing around with this today. If I hit the link, and again, don't laugh at my UI skills, but I made it different. Again, two different types of application. They're all running under the same role. It's scoping the permissions, it's giving credentials to the SDK client, etc., and it's integrated with X-Ray, so I can see what's going on in the hosting environment. Now, sometimes it might be that something goes wrong, and you need to get access to the instance. Remember I said that you could remote into the instance when you had the secure key pair? If I go to, let me go to the dev environment here, click connect to instance. Oh, actually I'm on the wrong IP for this one. Let me not do it from the Beanstalk app. Oh, actually it might work. Let's try it. If not, it'll just time out. Oh, it won't work because I did not open up the security port. Let me go to a different one. So, as well as Beanstalk inside the toolkit, I've got EC2, the compute instances. I can launch instances from here, just bare bones compute instances. Here I could launch Windows Server 2019, declare what compute horsepower I need by the type, etc., fill out some fields. Or I can go into an advanced wizard and customize the storage, etc., etc. It's full on wizard. For that, if I click on here and go to instances, my double click's not working. Wrong one. My double click's not working too well tonight. View. So here are all the running EC2 instances that I've got in the cloud. Here are the 2 Beanstalk ones, or the 3 Beanstalk ones. But let's just remote into this one. So again, the toolkit has the key pair for this stored locally, encrypted, it's not open. Click OK. This is one of my favorite features in the toolkit. Certainly when I was a developer and I was spinning up EC2 instances and deploying apps, I want to go and dig around and see what's going on. This lets me actually just get straight into the EC2 instance. See that this is different to my drive. So I can go in there and work with that. Let's see, what else do we have in here? So we've got a whole bunch of services on the right hand side. S3's here, so I can go and take a look at my buckets. So here's the bucket that I was working with earlier. If my double click works, browse. So here's the content. When we did that list objects call, this was the bucket that it hit. And you'll see that inside the toolkit, even though S3 isn't a file system, we present it like a file system. So I can drill in and out of these folder key path hierarchies, just like a folder. I can also drag and drop. So if I just want to upload some content into here, let's see, let's go to use groups, content. Let's just grab all of these. We'll use these later on. We get nice handy dandy drag and drop support into a bucket. I could have created a folder inside here to put them into, or a key path in here, etc. I can also click and download. This works, there we go. I can also download from here. I can make things publicly readable, etc., etc. Saves me having to go to the console to do this work. I can just do it directly inside here. Because we spend all our day in Visual Studio, right? We never go out of it, or Visual Studio Code. Alright, so this is the two, actually before I move on, so I want to go back to the ASP.NET Core one. Some of the sharp items, you might have spotted this file. AWS Beanstalk Tools defaults.json. So if we're running on Mac or Linux and we're using .NET Core, we can still deploy to Beanstalk. Right? We don't need to go to the console. We ship a set of global tools, .NET CLI extensions, for working with AWS at the command line. So we have some for Lambda, they're probably not the most famous ones we have. We also support Elastic Beanstalk. So this file here is used with the CLI and the wizard. You can round trip between the command line and Visual Studio using this file. The wizards pick up these values, the command line picks up these values. From the command line, I can do a redeploy using the right tools, Elastic Beanstalk, and then let's go to the .NET Core version. So here I am in that same folder you just saw in the solution. I have it installed, but let's just go through how you would do it. So you do .NET tool install -G, it's called Amazon.elasticbeanstalk. This is also open source tools. It's already installed for me, right? Because I have that defaults file, what that means I can do is let's just do the .NET EB, which is the command line extension for Elastic Beanstalk, help. So I can do deploy environment. All of these commands have help with them, so you can drill through, but once I have environment, once I have that done, I can do deploy from the command line, from on Mac or Linux or Windows. I don't have to go into Visual Studio. So when I'm using Visual Studio Code, for example, I can work with Elastic Beanstalk from inside VS Code using the terminal this way. And you can see what it's doing is the .NET Publish, the zip, exactly the same code that runs in the VS Toolkit. Shared code, and that'll wait for the environment to update. So that's a really quick way of getting started hosting application code on AWS, certainly web application code. Right? If you're using ASP.NET or ASP.NET Core, use Beanstalk. Let's switch gears for a minute, and I want to go and talk about PowerShell tools. So back in 2012, we released the first of the AWS tools for PowerShell modules, supported Windows PowerShell, which is all we had at the time. It still supports it. It supports PowerShell versions 2, 3.5.1 on Windows. We also support PowerShell Core or PowerShell 6, as it's called. That's a different module called PowerShell.NET Core. Both modules are distributed on the PowerShell gallery. So let's take a look at PowerShellGallery.com. And if we search for AWS PowerShell, so this is the first of the modules. This is the one that supports PowerShell. This is the one that supports Windows PowerShell. This is also pre-installed on all EC2 Windows instances. So you don't need to worry about this. You can deploy scripts to an EC2 instance that use these tools and just run them. They're automatically there. It looks like they had a new version today, which is cool. The other module, this one's the one for PowerShell 6, is called AWS PowerShell.NET Core. Both modules are pretty much identical. I think there are 3 or 4 commandlets in the Windows PowerShell module that are not in the PowerShell core, and that's because they're to do with SAML identity federation. We don't have the Windows APIs available yet to support those. The modules themselves map one-to-one to AWS Service API. So everything you can do in an SDK, you can do in PowerShell. Does anyone use PowerShell here? Awesome. Right. So once you install these, just install -module and the module name, you get access to a whole bunch of, this is still deploying out, let me open up a new window. Oh, it's just finished. Cool. Once you import the module, you get access to a tremendous number of commands, for which I apologize. Let's see what I have here. Currently 5,637 commandlets in that in both of those, each module. Right? I think the Netcore one is 5,633, something like that. We did not anticipate the scale of growth of AWS in 2012 when we wrote these modules. We code-gen them just like we do the SDK. So we're kind of in this tricky position now where we've got these mega-sized modules with all this capability in it, but it means we got these mega-sized modules with all this capability, right? I can script anything from PowerShell using these commands. One issue we do have is finding your way around. Right? So we have 165 plus services in AWS. The tools support around 150 plus services. Some of the ones just don't make sense for various reasons, but the vast majority are there. How do I know what it actually supports? I use a command called get AWS PowerShell version, and I add the switch list. That will list all of the services that are supported from PowerShell. Right? And you'll notice in the middle, there's this thing called a noun prefix. When we started developing these tools, we needed a way to effectively namespace the commandlets because services have the same API names across different services, which you'll see in a second, right? So we need to differentiate those. So what we chose to do was we contracted the service name down to like a little 3 or 4 letter prefix. Some of them are obvious, S3, EC2, etc. Some of them are not so obvious. This is one of the ways you can figure out what the noun prefix is for a given service. Once you know the noun prefix, or even if you don't, you can then run another commandlet called get AWS commandlet name. And let's say I want to find all the commandlets that have something to do with compute. I can give it that, give it a regex, etc. And it'll give me back the commandlet names. And it also gives you back, you see in the center here, the API that it maps to. In some cases, commandlets map to more than one API. There is, for the most part, there are one-to-one mapping. In some cases, we sort of, again, like the extension packages, we made these higher level commandlets that do multiple things, calling multiple APIs, and the service on the right that it supports. If you know the service prefix, let's go for S3 as a simple one, then you can just query on the service prefix, and that'll give you back all the commandlets supported for that service. Okay? And because they map to the service API, you can then jump to the service API for documentation. They all have help docs, but for the most part, it reflects the service documentation. What if you have, let's see, you know the API name, but you don't know the commandlet name, right? So EC2's API for getting information about what instances you have running is called describe instances. Well, we can look query on that. Get AWS commandlet name dash API operation, and then just give it the name, describe instances. You can see that comes back with 3 commandlets because 3 services have API operations with the same name. This is why we namespace with that prefix. The whole reason why we do it. If you go online as well, you'll find a lot of examples for the AWS CLI. This was the cross-platform CLI that we had before we had PowerShell 6. So obviously now PowerShell is cross-platform. So if you can find a CLI command, you can reverse encode that back to the PowerShell command. This is probably one of the most useful features of this commandlet. So what you do is you say AWS AW should do it, a CLI command, and you can just type in the command in the format that you see in the examples. Now, two things. One is you don't need the AWS piece. Okay, it's smart enough to know that that is relevant. The other thing is this is not going to translate the parameters back. It's just giving you back the commandlet that maps to that example, right? But because the CLI and PowerShell tools and SK are all generated from the same service models, it's a fairly easy translation process to bounce around and figure out what the parameters should be. Of course, PowerShell is somewhat different in that it has to conform to naming conventions. So we do things like singular parameter names, etc. Whereas the service teams are not fixed to that. They can have they can have plural names, but it's usually fairly obvious. So once we've done that, what can we do with these tools? So let's take a look. Let's do get S3 bucket, for example. This should look familiar. It's my bucket list from earlier on, right? You get EC2 instance. And that will give me back my set of reservations. When you launch EC2 compute instances, they're putting something called a reservation. It's like a grouping. So if you actually want to look at the instances, then because this is PowerShell, we're getting rich C# objects back, or .NET objects. We can look at it that way. Right. So from our command line, I can start messing around with resources, doing all sorts of stuff. Remember, I've got the full AWS service APIs at my fingertips of the command shell now. Right. What was I going to say next? Let's actually look at a real-world use of using these. Oh, actually, I know what I was going to say next. So far I've shown you the toolkit, PowerShell. Both those tools use the SDK under the covers, right? So everything that these tools are doing, that tree that you saw in Visual Studio, the views, etc., the PowerShell tools, that's also available to your applications. There's no hidden APIs being used here. This is all the same public APIs are available to you. The other thing I wanted to do before I show you the VPC example, and code deploy example, is show you an upload. So you saw me do that. You saw me do that drag and drop operation inside Visual Studio, right? So here I have that bunch of files. Right, S3 object, bucket name, key prefix, because I'm going to upload a set of files. Let's call it test dash folder, current folder. Should do it, and I don't have any subfolders, but if I did, dash recurse would follow them through. And here's an example of where we've hooked up to the event trace that's coming back from that transfer utility. That's what this is doing under the hood. It's just called the transfer utility. So again, exactly the same functionality that's available to you. If I want to download, I use read S3 object, and I can download entire key paths or single objects, etc. Okay, let's take a look at just the Visual Studio code, and what I want to do here is look at a script that is going to stand up some infrastructure. So infrastructure as code is the current big thing. So yes, I could go to the AWS Management Console here, and I could go to services. Let's go to VPC, virtual private cloud, and I could launch a wizard here that would create a virtual private cloud on the AWS cloud itself, right? With public private subnets, etc., etc. But clicks don't scale. So what we want to do is encode that. So that's what this commandlet does. New iOS Web Server Fleet. It does a lot of things using the tools of PowerShell. So it's an example of what you can do with these tools. So I'm going to give it a VPC name. It's a logical name. I'm going to give it an instance profile name. That's a role, effectively, that the compute instances that this script's going to launch is going to assume. So we saw that with the Elastic Beanstalk thing. That's going to give my credentials to my application, as well as scope what that application is allowed to actually touch in terms of resources and APIs and services. Some of the stuff is defaulting, but what it's doing is, you may not be for virtual private cloud, I don't want to delve into it too much, there's a lot of docs on the AWS site, but basically what it's going to do is, for a given region, it's going to get the list of all the availability zones inside that region, right? So that's how AWS partitions regions, and availability zone is 1, 2, or more data centers, usually 2 or more. I think it's always 2 or more. Get those zones, and then it's going to create a VPC for that region with an address range. All these commandlets you're seeing here are from the tools for PowerShell. It's going to attach an internet gateway because that VPC by default has no access from the internet. It's a private cloud. Attach an internet gateway, that's going to give me access to the inbound access to my VPC. Attach that to the VPC, and then for each subnet, it's going to walk. For each zone, it's going to walk through and create a public subnet, which has access to that internet gateway, so it can inbound traffic can get to that subnet, and a private subnet. This is kind of a reference way of building some. All my compute instances I'm going to have my application running on are going to be in the private subnets. They have no direct access from the internet, right? So they're secure. Everything has to come through my application load balancer it's going to create later into the public subnets and then route to the private subnets. Security groups that control access. So once that traffic gets in, what ports are going to be open? In this case, port 80. Routing tables. These are controlling the access to the subnets from the internet. Elastic IP address, so everything, my application load balance has one address. Route table, it's going to be a bit more. Then I'm going to create a load balancer. Target group for that load balancer. It's going to target my EC2 instances that are going to be running inside the private subnets, etc., etc. Then what it does, handy commandlet here, get EC2 image by name. So EC2 every month revs its images, right? The compute instances, whether Windows, Linux, whatever. Which means that over every month, the image IDs change. The image IDs that we use to reference those images that we want to launch. So the Windows Server 2016 base image that I'm going to use here today, in a month's time will be a different ID, right? So using this commandlet, if I'm in PowerShell, or you can use it, do this from the SDK, I don't need to hard code the image ID. I can just look it up dynamically when I need it. What I'm going to do then is set up an auto-scaling group, again using these tools, and then for each EC2 instance, because I'm launching a bare bones EC2 Windows Compute instance, it has nothing installed on it, right? So it's going to install IIS with ASP.NET support, etc. Download and install Chocolatey. That's going to let me get hold of, here's how it downloads web deploy, because I want to deploy web deploy archives to this. Install that. Then I'm going to download the code deploy agent, which we need running on the instance so that we can do deployments using code deploy from S3, read S3 object, and then run it. That script's going to run on every EC2 instance that this scaling group starts. So if I increase the size of my scaling group for a particular reason, every new fresh instance will run this script and be ready to go, and then I can target it for code deploy. So let's just run this, and new IIS, and I said I'm just going to give this a name. Where are we? We're in the Southeast Valley, right? Southeast Valley. I'm not going to use this one, but here's it, instance profile name. This is my instance role that I use. It covers what these instances can do. This will run and create all those resources. Right? And now I can take that script and I can run it as many times as I like. I don't have to repeat the clicks in the console, etc., etc. So that's one real-world use of the tools. What I'm going to do once this is up and running, I already have one running. So you can see here it's waiting for the completion of the NAT gateway. The NAT gateway allows the EC2 compute instances that are in the private subnets, which have no internet access at all, access out to the internet, but not inbound access. Right. Just let this finish up. Everybody with me so far? Yeah? Any questions? Cool. Can you all hear me okay, or have I gone quiet?
Good.
Good? All right.
Good enough.
Good enough. While that's running, let's take a look at another script I'm going to run. So this is going to set up the infrastructure for AWS code deploy. So when we deployed to Beanstalk, remember what we chose two things, right? We chose a solution stack, which is either Windows or Linux, that governed the resources that the stack, the Beanstalk environment's going to run. And we chose the EC2 compute instance size, right? When we use code deploy, we're stepping down the stack a little bit more towards the metal, right? So I'm going to launch, or I'm going to tell it what EC2 instances to run, or to launch, right? I'm going to have more control. I have to install the code deploy agent so I can do deployments to it, which I didn't have to do with Beanstalk. It already has an agent installed that can do all that work for me. In this case, I'm stepping down a little bit closer to the hardware. What I need to do is then create a code deploy application and a deployment group that targets those EC2 instances, right? So that's what this script does. takes an application name, a logical application name, an auto-scaling group name, and a service role, which again, the service role is used so that when code deploy is running on those instances, that governs what it can do, right? Again, fine-grained permissions, by default, it can't go and mess with things in your account. This one is still running, I think. It's slow tonight. I'm not going to use that one anyway. So, let's move to a different window while it's running, and let's go back to Valley. How are we doing on time? Deployments, and I'm going to go to code deploy. So this is the set of scripts that we've got here. Let me run the code deploy application one. So my application name, I'm going to call it valley.net UG. That's where I started earlier on. I think that's my VPC. Let's go check. What VPCs do I have? Seems like a bit sluggish. VPCs. Valley DNG. So that was launched earlier on today with that script. So that's what I'm going to use for my application name. My auto-scaling group is the same name. I have to know by convention. And the, the service role, I have one set up called code deploy service role, which just basically governs what that agent is allowed to do on that instance. Okay, so let's set up my code deploy resources. Let's go and take a look at what that looks like inside the console. So code deploy. So here's my application. EC2 on-premises has a deployment group, and that deployment group identifies the instances that I'm going to deploy to. And it does that by, it uses the auto-scaling group name. So all the instances in that auto-scaling group will automatically target for deployments. Once I have that, now I can do a deployment. So I have another script. That one is now finished. Cool. So another script here, new code deployment. So inside Visual Studio, we saw a deployment using the wizards. For SEVDNUG Core, we saw it from SEVDNUG Core, we saw it in the toolkit using the wizard, or from the command line. I'm using code deploy. We don't have support for that in the toolkit, so I'm going to do it from PowerShell. So I have another script here that just basically takes a bundle, web deploy bundle, and is going to deploy that to code deploy. And it does some work for me. So let's run this one. Oh, actually, before we do that, let me show you what the code deploy bundle looks like. So when we did the deployment for Beanstalk, what we built was a web deploy archive, and that was what we uploaded to S3 for Beanstalk to go and download. For code deploy, we need to do one extra step. So code deploy needs to know what to do with the web deploy bundle when it gets down there, because it doesn't understand web deploy by default. So let's go and take a look at the archive that I built, and you'll see here's my web deploy archive content, right? The big long path thing that we were talking about, plus the web deploy scripts to actually install. At the top, you'll notice there are these two files, an appspec.yaml file and a script, PowerShell script. Take a look at the appspec file first. So this is what indicates a code deploy deployment. And code deploy has some lifecycle hooks that you can attach scripts to, courtesy of this file. It tells you what to do at each given step. Right? So here, after the install, which is after I've got the bundle down on the instance, I'm going to run the script, install that.ps1 script that's sitting inside my bundle. Here's the script. Review, and all that's going to do is run that archive deploy command and install into IIS. Pretty simple. So that's how I have to form up my code deploy archive. It's not just the web deploy bundle. Inside here, to do a no code deploy deployment. So my application was called Valley DNG. My deployment bundle is the zip file that I've just shown you. Star.zip. There. Bucket name, I'm going to put that into my usual bucket. My archive key can be anything. Let's just call it valley dnug.zip. I think that's all I need. A deployment group name, it will take that from the, I think by default it takes that from the application name and attaches deployment group. It's a shortcut. So this will emulate what the toolkit would have done. You see it's come back with a deployment ID. Let's go see what's going on. So we've got deployments here in the console. There's my deployment now running. And you can see that one instance is currently pending, the other one is working. Click on this. Oh, no, I don't want to go there. My bad, sorry. Oh, that one. One's done. Oh, that's where I wanted view events. So you can see here are the lifecycle hooks that I can attach to. You can't attach scripts to every one of these, but the important ones, you can certainly do that. So that application is now out and actually on .NET. Should have finished in both. This is all sitting behind a load balancer. Remember in that script I created a load balancer that was targeting those instances to pass the traffic to. So I need to go and find out what that load balancer URL is. And I can do that again from the PowerShell tools. Get ELB2 load balancer. This will list all the load balancers that I have. I currently have 2 because I did a deployment earlier on that we're not using. The one I want is Valley DNUG. Here it is. So if I hit that URL, let's go to my here. What I should get is the IIS homepage. Oh, because I deployed, when I built that sample application, the web deploy archive, I told it to register as a /sample. So I can see the difference. I could register it as a default website, which is what Beanstalk does for you. Hit sample, for a few seconds this should spin up. And again, don't laugh at my UI skills. There it is, ASP.NET up and running on a bare bones EC2 instance that had nothing installed on it prior to me launching it, but it configured by that user data script, and it's inside an auto-scaling group. So let's say for some reason this simple ASP.application suddenly got hugely popular, right? And the auto-scaling group started to spin up new instances. They would automatically be configured ready for deployments. And I could trap that life cycle of, hey, we've launched a new instance, and then trigger that code deploy to run again. Right, that's the PowerShell tools and code deploy. Let's see, where do I want to go next? Oh yeah, serverless. So, finish up. So, inside the toolkit, back in, I think it was 2017, AWS launched something called Fargate, which was serverless containers. So, previously we would have to launch EC2 instances in clusters, then deploy the containers to those EC2 instances. With Fargate, it takes a service approach where we look after the infrastructure, you just worry about your code, right? And what we did, we built tooling in Visual Studio to support it. So Elastic Container Service is surfaced inside the Explorer. Let's go and view this cluster, the one I deployed earlier on. And if I go and hit this URL, it should launch. That's my containerized application. Again, very similar. You'll notice this one's not listing buckets. Again, so it looks different. Close this off. But how did I get that out installed? Or how did I get that deployed? You'll notice there's a Docker file inside this project, right? ASP.NET Core. I've added a Docker file. And then if I right click on the project, you'll notice that I have 2 options now. Publish to Beanstalk. This is still an ASP.NET Core application. I can still deploy this to Beanstalk. No big deal. Or I can publish it as a container. If I publish a container, I get a different wizard, and I get a number of options. So I can either deploy it as a service, which is meant for long-running tasks like web applications. A task, which is an application that basically starts, does something, and shuts down. Schedule task, or schedule task, where on a schedule it will start up, do something, and shut down. Or I can just deploy the container image, these 2 Elastic Container Registry. I could walk through this wizard, and here I've got either create a new cluster. This would let me do a brand new cluster. Again, Fargate is the default option, so serverless. If you have an existing cluster of EC2 instances you want to target, then you can do that from the wizard as well. I don't have one, so I should use this. I'm not going to run this wizard necessarily here, but basically it's the same idea that you saw with the Beanstalk wizard. It'll do all the packaging for you, it'll deploy it out to the container registry, and then tell ECS, hey, go and deploy this container image on AWS. The reason I'm not going to do that is, just like the other tools, there's a defaults file, which means I can do this from the command line. All right, so we'll deploy it there. To do that, what I would do is let's just go to ECS under here. So here's my project folder. Cool. So here's the folder I need. The tool is amazon.ecs.tools, the global tool. But once I have that installed, .NET ECS help is the right command. You see, just like the Beanstalk one, I have these options: deploy service, deploy task, deploy schedule, or push an image. Just do deploy service. They'll take the defaults in that file and run them. So there's the Docker build going on. See, it does you need to log into ECR before you can push the image. It does that for you, pushes the image, and then tells ECS to deploy it out in the container. Okay, nice and simple. And this is how you would do it from a CI/CD system, right? All these tools inside Visual Studio, they're really designed to get you up and running quickly, right? I'm not saying you should use these in production to deploy production apps. You would move to CI/CD, right? But these are the way you can experiment and get started quickly. Talking about CI/CD, let's just switch gears there. How would we do this? So probably many of you, well, I'm guessing that some of you use Visual Studio Team Services or VSTS or Team Foundation Server, Azure DevOps Server. This is Azure DevOps Server 2019 running on EC2 instance. How would I deploy from here? Right? So I have a build pipeline set up in VSTS DevOps Server. Moving builds is costly. I've done this myself, right? Moving build pipelines between build servers. You always make an error somewhere, right? Yes, AWS has its own code services, code build, code pipeline, code deploy, etc. But if you have an existing build pipeline, why not just reuse it, right? All you want to do is now target AWS. So back in, I think 2017, Microsoft came to us, interestingly, and said they'd been doing some queries on the marketplace, looking for what were people looking for. And far and away, the most popular thing was AWS. So they created a proof of concept extension with, I think, 4 tasks in it. Came to us, came to my team, and said, do you guys want to own this as an open source project? And we're like, heck yeah, we'll have it. So we took it, and in a couple of months we added a bunch of tasks, and we added a whole bunch again last year, released it to the marketplace. It's called the AWS Tools for Visual Studio Team Services. We have not yet rebranded it with a new name. So you just search for AWS. Here it is. And it's free download. You install that onto your TFS server or your VSTS instances or your DevOps server, what happens to be. I already have it installed. When you do that, well, what can you do with it? So I have 2 build pipelines here for those Beanstalk projects that we were using earlier on, the ASP.NET and ASP.NET Core. Already set up, save us some time. So let's go and take a look at the build pipeline for this one. Now remember I said that we were building a web deploy archive, right? The other one just does .NET Publish. It's the same basic process. You'll see here, there's a task at the bottom, deploy to Beanstalk. Right? How did that get there? Well, once I have this installed, I can go and add a bunch of tasks. And these are the tasks that we have inside the tools. So we have AWS CLI. You do need to install the CLI first on your build agent. If you're running TFS, then this is a simple job to do. If you're running VSTS, it's not so simple because you get a fresh build agent every time, right? Build host. But you do need to pre-install this. We don't do it for you. But once you've got that, you can run AWS CLI commands. We can create stacks using CloudFormation. That's our infrastructure provisioning service. We're going to see that shortly, where you basically give it a declarative template written in JSON or YAML that says, these are the resources I want to spin up in the cloud. Make it so. Right? You saw in that PowerShell script where it was waiting for that NAT gateway to be created. Right? CloudFormation does all that for you, which is one of the nice things. Right? You just say, I want this, do it. Right? And it'll just spin up the stack. I can delete the stack. Oh, the other thing about create update stack that's nice is that if the stack exists, it switches to update mode. You don't have to worry about testing, does the stack exist first? So if you're like doing repeated updates to a stack, like you're changing the template, you can just keep rolling that. Change sets is another CloudFormation feature I'm going to go into. Code deploy, that code deploy application I just did from PowerShell, I can do inside these tasks here. Again, it's a simple point and click interface. Beanstalk has 2 tasks, create, version, deploy application. Look at it in a minute. I can push container registries. I can't do ECS deployments, or you can't do ECS deployments from these tools, but you can use that command line tool I just showed you to do it, right? Because that defaults file is round tripping in Visual Studio. Any changes you make on your local dev system are going to be checked in, so it'll be fine. I can deploy Lambda.NET Core functions or service applications, or if I'm using some of the other languages that Lambda supports, like Java, Go, etc., I can deploy them here, deploy function. I can invoke Lambda functions from inside my build pipeline. So if I have a function I want to run and do something in the cloud, and then just shut down, I can actually run it from here. I can download content from S3, upload content. I can get secrets from Secrets Manager, which is one of our secure Vault API services that we have, or create them. And then, so if I have secrets in my build, like connection strings, passwords, etc., I can recover them dynamically at build time. When they come down into the VSTS DevOps build environment, They are flagged as secure variables, so they won't appear in any output. They're automatically masked, right? So you're not going to leak any secrets that way. I can send messages to SNS topics or a queue, which may be interesting if you've got a Lambda that's hooked to an SNS queue that you then want to fire as soon as a new topic, a new message arrives. I can configure a shell script with AWS credentials. I can use Systems Manager's parameter store, which is another one of our stores. This one lets you store string values, string list values, or secure strings. And again, if it's a secure string that you're reading back, you're not going to see it in the output. It's automatically masked. Run command, I can target a fleet of instances with a command document. Doesn't matter how big that fleet is. I have a command document, which can be PowerShell. And then say, hey, these thousands of EC2 instances, go run this command document against them. That will go off and do that. I can run the tools for Windows PowerShell. It doesn't support PowerShell Core, it does Windows PowerShell. This one does automatically install if you don't have it. So it's kind of helpful. So I have a whole bunch of tasks available to me. Once I have the task, what do I do with it? Well, I add it to my build, and then I just configure it. So just like we saw with the SDK, you know, it's going to need credentials, and it's going to need a region. Right? There's a couple of ways you can do this. When you add the tools to your install, there's a thing added called an AWS service connection. Right? If you do service endpoints in VSDS, in the drop-down you'll see AWS. That'll give you this dialog. It looks like a credential profile, right? You give it a name, you put the access key and secret key in, and then you store it. It's all securely stored. Or if you want, you can use assumed roles, like the services do on the deployed applications, which I'm not going to go into. So you don't need to use fixed credentials. You can get temporary credentials. But once you put that in, then you can select it. I don't actually have any here. The reason I don't have any, this instance of DevOps server is running on EC2, which I started with an EC2 with my EC2 instance role that says, give this credentials temporarily when it needs it. So the tools will automatically get from the EC2 instance credentials they need to run to call these tasks. Similarly, region, I can configure the region I want this build to run against, or if I leave it blank, it'll figure out from the EC2 instance it's running on. If you're running on your own on-prem TFS server or VSS, then you're going to need to fill these two out. But once I've done that, it's pretty simple to use. I use the application name, the Beanstalk application name, the environment I want to target. It supports an ASP Web Deploy archive, ASP.NET Core archives, a bundle I've already deployed to S3. So let's say I'm doing a Java application that I want to host, right? I'm going to build my Java jar file somewhere else, upload to S3, and then just reference it in here. Or I can use an existing application version. That one's useful. I mean, not everybody does deployments to host systems from their builds, right? You do the build, you get the artifact, then you have a release pipe that actually does the deployment, right? That's where you use the existing version mode of this in the release pipe. So you build, creates the application version using the other task, and then you deploy that version. And then all I need is the location of the web deploy zip file. All these steps here are built. So it's a really easy point and click interface. Just fill it out, queue your build, which normally you would just have configured to run on a Git commit. In this case, I'm going to do it manually. Agent ready for the job, off it goes. And again, just like the tools you saw in Visual Studio, PowerShell, under the covers, this is using just our public SDKs. Right? In this particular case, it's using our Node.js JavaScript SDK. These tools are open sourced on GitHub. So we really like pull requests on these because we set out with the intent of what the most common things that we think people are going to want to do, and then over time people have pinged on the issue and say, hey, I want to support ECS, or I want to do Secrets Manager, etc. We've added those over time. So you can see the Beanstalk task running now, figuring out credentials, etc. So we'll leave that one to deploy and move on because it's 8 o'clock. So the last one I want to show you is a new application I've been working on to demonstrate serverless Lambda functions and step functions. Are you all familiar with serverless functions? Some of you are. Yeah, the idea of a function that runs, it sits in the cloud, it's not doing anything, you're not being charged for it. An event happens somewhere, Lambda starts your function, runs it, and shuts it down again. Right? Step functions are like a group of Lambda functions that are in a state machine, and the state flows between those step functions to do some work. So what I've got is something called what I'm calling the media ingester. And it came about from some demos that we were doing with, if you look on YouTube for reInvent, you'll see various demos of us doing image recognition using the recognition service, where we take an image and we look at it and we say, hey, with a confidence level of X%, these are the objects I found in the image, right? And then we've been applying those as tags on the S3 object that triggered that Lambda function to run. When it was uploaded, the Lambda ran, applied labels. So I was thinking, wouldn't it be cool if I just had a workflow that could take any media and then do something interesting with it, right? So if I upload an image, well, an image or a video, we're going to check it. Is it safe content to start with, right? Imagine a feed on a website where users are just pushing content to something, right? It's coming into a bucket, an S3 storage bucket. It's being filtered to make sure it's safe. And then we're doing some analysis on it using the AI tools that we have, like Poly, Transcribe, image recognition, etc., to do interesting work. So that's what I built. So first I have a Lambda function here written in C# that is my triggering function. So when an object is uploaded to an S3 bucket that I'm going to configure, this Lambda is going to run. And you'll see that it's instantiating an S3 client, just like we saw earlier on. Notice I'm not giving a region this time. I don't need to. Lambda knows, it will know from Lambda what region it's running in. A step functions client. We didn't see this one earlier. This is the SDK for step functions. And simple systems management here is because I'm reading back a value from parameter store, which is the Amazon resource ID, if you like, of the state machine that I'm going to launch later on. So this is all fully dynamic. But basically what this does is it gets an event object from S3. Inside that event object is a set of records that record the bucket and the key of the object that was uploaded, so that trigger this Lambda to run. Once it has that data, it passes it to the state machine in terms of bucket name and the key in a state piece of JSON. Calls the step function line and said, hey, start execution. Right? And it'll do this for every object that uploads. Lambda is a horizontal scaling service, so if I upload millions of objects, millions of Lambdas will just start, run, shut down. Right? And when they shut down, I'm not being charged. You can do 1 million requests a month on Lambda for free. No charge. So you can really go some with this. The step function, in fact, let's just deploy this one out. To do it, I just right click, publish the Lambda. Or if I'm at the command line and I've got the amazon.lambda.tools global tool installed, I just do .NET lambda deploy dash function. I have that defaults file with all my settings in. Then you'll notice that if I go back a step, this option is on all these wizards that have this defaults file, so it will automatically populate the first one for you. You don't need to go and write it yourself. Click next. And let's upload this out. So this is my role that's controlling what this function can do in terms of all it's allowed to do is get data on the S3 object and execute a step function, nothing else. Just upload it. So this will do a .NET build, package it up, etc., and hand it off to Lambda. Done. My Lambda's up and ready to run. Not quite ready to go yet because we need to configure the event source. We'll do that in a second. The other part of this process is the actual step functions. So this is a state machine, and we define the state machine in a JSON file. It looks like this. So basically, the state machine has a series of tasks. The first one here is called determine content type, and you'll see that this is defined as a task, and it has this wonky syntax here, this dollar syntax. When the toolkit deploys this, it'll go through and substitute all this data for you, and reference a whole load of stuff. You don't need to worry about it. But basically, once we've determined what the content is it an image, is it a video, is it a piece of audio, is it a text file, it's going to do a branch. And then it's going to jump off to different Lambda functions. For videos and images, it's going to check for unsafe content. If it's audio, it's going to convert it to text. If it's text, it's going to convert it to audio. These are all Lambda functions that it's referencing. And at the end, it's going to send a completion notification to say, hey, I'm done, which in turn could trigger other Lambdas to run, right? Here are the individual tasks for if it's unsafe. If it determines it's unsafe, then it will abandon the flow, etc. How we wire these together is in something called a serverless template. This is a serverless application. This is a CloudFormation template. The toolkit, by the way, has IntelliSense for these templates for the JSON formats. Makes this really easy to use. But if you've not seen a CloudFormation template before, this is what it looks like. Certainly in JSON format, it also has YAML. So I can parameterize my template. So I can pass in the bucket name that I want it to use. I can change that on the fly, or when I deploy the template. The bucket key path, I'm going to write my outputs, in this particular case to an outputs key, and the voice that I'm going to allow my users to use. And the resources are the actual Lambda functions. So you see here the handler, This is the Lambda function that's going to be used. So this is the assembly, the namespace, and the function, or the method. Notice that code here, S3 cook, S3 key, is blank. When the tooling deploys this, what it'll do is it'll take a copy of this template file, it'll do the builds, create the zip files necessary, and it will inject the locations of those in S3 into this copy of the template for you. So you don't have to worry about this. If you do want to worry about it, let's say you've got a Java Lambda function that you've pre-built, so a Java somewhere, then you can edit in here and the toolkit will leave it alone. But by default, the toolkit tries to help you as much as possible here. So I have a bunch of Lambda functions. I have an SNS topic that I wanted to launch that I'm going to use for some email notification. And then I have a state machine declaration. And this is the most helpful piece of all. You see this definition string here? It's empty, right? That's where the state machine is supposed to go. Right? Who likes escaping JSON to put into a JSON file? Because I sure as hell don't, right? What the tooling does, look at the tools defaults file here. See this template substitutions key? The toolkit will take that state machine JSON file, escape it, and put it into the template copy for you, right? Which is a huge time saver, especially if your state machines are quite large, right? You have to worry about it, does it for you. You can see here some template parameters that I selected on last run. How does this work in terms of code? Well, here's the state machine itself. So when you run a step functions workflow, you have a state object, which is a C# class for .NET Core step functions, and this is passed between each of the lambdas that run in the state machine. The serialization, deserialization to JSON is taken care of for you. Remember in the lambda function, the triggering function, I had this as my input, right? That's the start of my state. It's a JSON string. That'll get deserialized into this state object. Bucket, key, content types, etc., some other fields. As my step functions run, they will populate data into this state object. As each individual lambda function exits, the state object will be serialized to JSON and handed to the next step function automatically.
How easy is it to debug something like a Lambda locally?
So to debug a Lambda locally, we have something called the Lambda local test tool. Right. So if I'm in Visual Studio, say I just had my ingested trigger here, this one, right? If I hit F5, it'll launch a web application locally that simulates a Lambda environment. So I can paste in the JSON payload that it's going to receive, and then step through the code. That's one way of doing it. We showed that at reInvent last year in a session. The other way you can do it is, now that I've got that Lambda function deployed, so here's the Lambda function I just deployed, right? I can do a sample request here. So I could pick a sample request that we've pre-canned for you and then edit it, or I can just paste my own JSON in here and hit invoke, and that will actually run the real Lambda and give you back the response, right? And then you'd have to go and look at the logs to see what happened. We don't support remote debug of Lambda functions currently. So you either have to use the mock Lambda test tool or this way of doing it. Let's see, where was I on the state machine? Oh yeah, so we had the state. So here's my step functions, which are my Lambda functions. You notice here I'm newing up all these clients, poly, transcribe, etc., just like we saw in that very first demo. Newing them up, and here's my actual Lambda function. So here's the first one, determine the content type, which all I'm going to do is look at the extension, image, etc., put that data into the state and exit. Next one's going to run to say, okay, if it was a video or an image, in this particular case I'm going to punt on videos because that needs to be an asynchronous operation, but basically, is it safe, etc., fill out the state object, and hand it on. Right? So let's deploy this part of the workflow. Again, publish to Lambda, but this time the wizard's different. We're publishing a serverless application. It has a CloudFormation template, so it's going to call CloudFormation to do the work. Right? I'm just going to hit publish here because it's already populated the settings I want. So nowhere in this process so far have I spun up any EC2 instances, any ECS clusters, etc. Right? I just don't care anymore. All I care about is my code. Right? That stack's going to spin up now. So now CloudFormation is taking that template, spinning up the resources that it defines. if I was doing this from the command line using the global tools, I'd do .NET lambda deploy-serverless, because it's a serverless app, not a single function. Should take a few more seconds.
One more quick question.
Yep.
The state object, right? It can pretty much be any object, right?
It's just a plain old C# class, anything you like. Yeah. As long as it serializes to JSON, of course. But yeah. Okay, stack's done. That's up and running. Cool. So I have a couple more things I need to do. But before we do that, let's go and actually take a look at the step functions that we've just deployed. So here's my state machine. And if I take a look at definition here, here's the actual. It's unfortunate this is not a movable pane, so I can't. There isn't anything on this left-hand branch here, but you can see that it comes into the branching workflow, and then if it's an image or a video, it's going to come through this path. Content or audio are going to come through these paths, and then at the end it's going to come together and say just send a notification, I'm done. So two things to do to configure this to run. First thing, I need to go and configure that trigger function so that it fires when I upload an object to an S3 bucket. Right? I could do that in the console, but since we're in Visual Studio, why not do it there? So let's open up the function details, event sources, add. I want Amazon S3, but here are the supported event sources inside the toolkit that I can attach to. I get my list of buckets, so I'm going to use this bucket, and anything uploaded to the inputs key prefix is going to fire this event. That's configured. Now what I need to do is, remember inside the template, I created an SNS topic for email purposes, right? This is how I'm going to send a notification out. This particular demo, I'm just going to use an email. So I just need to go and subscribe my email to that topic. So let's go to SNS. And go to topics. Here's my topic. So let's create a subscription to that. And I believe let's go and create an email subscription. This could be whatever, but this makes for a more visual demo. So that's my email. Create that subscription. If I go to my Gmail inbox here, I should get a confirmation email saying, hey, yeah, there it goes. I've been subscribed to that topic. Confirm it. Okay, so the end-to-end workflow is now set up. All we have to do now is trigger it. So let's go back to Visual Studio, and just like I showed you earlier on, let's open up that bucket. Go to the inputs folder and put some content in there. So let's see, what have we got here? Content. So let's take Sean Connery, some audio. Oh, actually, before I do that, I just want to show you what the text is. This is the text that we're going to convert to audio. So Steve here, new blog post, blah blah, etc. So when it sees that text file, it's going to convert that to audio. And that audio there is actually the results of it. We're going to convert back to text. See how good it does. So I take the bridge, I know Tim Dalton, Sean Connery, the audio, the text file, the waterfall, the critter, Seattle. Let's upload those to my bucket. Now we should see that the lambda function is run. So go to step functions. We should see that the step function actually, yeah, one's running already. So it's pretty quick, right? That lambda fired pretty quick. In fact, all 6, or how many I uploaded, are actually now running. If I go into an individual run, you can see that we came into determine content type. The input was the name of the bucket. Remember from that trigger function, this is where it passes the JSON. The code itself saw a C# class and the key. The output from that step was, it declared it as an image because it was a JPEG file and handed it off. Unsafe content check ran. There's the input object that it got that was from the previous step. On the way out it said, yeah, I'm cool, there's nothing wrong with that. Then it went to look for are there any media content, so now it's looking for keywords. So you notice on the input the keywords list is empty, but on output it detected bridge, building, suspension bridge, city, urban, etc. These are all the AI services that we have running. At the end it sent a notification saying we're done, we did not find any celebrities. Right? Interesting, I noted the other night when I was testing this that image recognition can recognize an old Sean Connery but it can't recognise a young Sean Connery. I don't know why. I was curious about that. They've all succeeded. This one's still running. Let's see what this one's doing. That was an image. Was it a celebrity? Let's have a look. Checked a media celebrity. No, that one was not one. Of course, you're not going to know which one was which. Let's see what object this one was. Input. That was the audio. One of these would be a celebrity, surely. Let's have a look. No, that was the bridge. Oh, well. One of these would be. That was the audio. Ah, that was the Sean Connery. Let's see, did it recognise the old Sean Connery? Output, didn't say it did, check. Celebrities, yeah, there we go, Sean Connery. Right, so identified that. But what did it do with all that information, right? It went through all those multiple paths for the different image types. What happened to it? Well, if I look at my emails, it should have sent notifications. There they go. They're finished. Now, email's not a lot of use to me, but you can see the output structure that came out, the state object that had flown down, which is what I just chose to output. But I could have subscribed a Lambda function to this topic, so my system of media ingestion from multiple users is, take the content, check for safety, look at it, is it good, do some image resizing for web, etc. Fire that SNS notification, and another Lambda pick up and start doing other work with it, right? Putting it into some content system, or if I was using my next plan for this is to actually have an ASP.NET Core website running on ECS with SignalR, and it will just continually update as new content comes through. But I hadn't quite got that far before I flew out, so we have to make do with email, sorry. So that all ran. That's cool. Nowhere did I spin up any EC2 infrastructure. Nowhere did I spin up any infrastructure, in fact, right? The system, the cloud just took care of it all for me. All I had to do was deploy my code. Really nice and simple. I think that was all I wanted to say about that. Yep. So we'll just finish up with these slides. So, wrong one. That one. So what we looked at, eventually, when it comes up, that's my picture, by the way. It's Matt. She's not going to come up. Oh, my desktop has gone back to its full 4K scaling. Let's just go.
That was Bellevue, right?
Oh, there we go. That was Bellevue, yeah. Mount Rainier last summer, July 3rd, midnight. So we worked, how to work with the SDK for .NET using the NuGet packages. One NuGet package per service with a common core runtime. How to construct the clients, how to call the APIs with the request response classes, etc. Using the Explorer in the Visual Studio to get around, using some common services, S3, EC2, Beanstalk, etc. How to quickly get started with ASP.NET and ASP.NET Core using Beanstalk. Just, here's my web app, host it, right? Really simple. Went through the PowerShell tools, how to do command discovery, what commandlets map to what APIs, etc. And then some real world usage of actually spinning up some pretty heavy infrastructure in a virtual private cloud using it. Which of course I could also have done with CloudFormation with the master JSON. I have done that, but I prefer the PowerShell version of it, frankly. Using DevOps Server to reach out last mile to AWS from my existing build pipelines, and then we just did a bunch of serverless deployments for Visual Studio. The links, I think you can just about read that blue. I have no control over it, I'm afraid. But the .NET homepage on AWS, so aws.amazon.com/net will take you to the .NET homepage that we're updating. The GitHub homepage for all the tools that are open source or other extension libraries, github.com/aws/.net. And then on the developer blog, we blog there quite regularly on .NET and PowerShell. Those are a little bit longer, but if you go to the aws.amazon.com/blog/developer, you can then do a filtering search for .NET, .-NET, or PowerShell. With that, thanks very much. Hope that was useful. Feel free to reach out to me if you want. My Twitter handle's there, @BellevueSteve, or you can email me directly, strobe@amazon.com. If I don't know the answer, I'll go find somebody who does and get back to you. So that's part of my job. With that, I'm done. Right? And you're out.